Hi everyone, what is the least common multiple of 24, 42, and 60? Let's find out here in this video. Before we look into the concept of least common multiple or LCM, let's go back to the concept first of multiple so that we can understand it in the easiest way possible. Alright, so let's start with the concept of multiple. By reviewing the concept of multiple, it is the product of a number with any integer. Let me give you an example for you to understand what a multiple is. Let's say, for example, we're going to get the multiples of 4. So let's try to figure out what all of the multiples of 4 actually are. Let's say 4 times 1, which is equal to 4. The next one is 4 times 2, which is 8. 4 times 3, we have 12. 4 times 4, we have 16, and etc. So 4, 8, 12, and 16 are all multiples of 4 because it can be obtained by the product of 4 and the integers 1, 2, 3, 4. And we'll basically use this to help us in understanding the concept of LCM. Alright, so now what is LCM, or the least common multiple? And from the word itself, it is the smallest counting number that can be divided by the given numbers. So from the word can be divided means this one serves as a dividend. Alright, let's have an example. Let's say we're going to get the common multiples of 4 and 8. Alright, let's start with 4. So the multiples of 4, we have 4 times 1, which is 4. Then just add 4, we have 8. Add another 4, we have 12, 16, 20, 24, and many more. Next one, we have the multiples of 8. So 8 times 1, which is 8. Let's add 8. We have 16, 24, 32, 40, and etc. So as you can see here, we have 8, 16, and 24. And if we try to reach 100, then we have more multiples of 4 and 8. But let's focus on the smallest since we are talking about the LCM here, which is the least or the smallest counting number. The LCM, or the least common multiples of 4 and 8, is equal to 8. Alright? And in here, you can notice that the least possible value of LCM is the greatest value in the given numbers. So in LCM, we have another method. We can basically apply the concept of factoring to get the LCM. Since let's say we have 8, a number is a factor of 8 if 8 is a multiple of that number. For example, 2 is a factor of 8. All right. 2 is a factor of 8 if 8 is a multiple of 2. All right. And we all know that it is true. So how can we use the factors of the given numbers in getting the LCM? Let's have another example, and we're going to get the LCM of 12 and 20. All right. So instead of getting their multiples, let's use the same table that we used in getting the GCF. All right. So let's start getting the factors of 12 and 20. So we have here 12. And what are the factors of 12? We have 2 times 2 times 3. Next one, the factors of 20, or the prime factors of 20, we have 2 times 2 times 5. All right. By putting it in this table, by putting it in this table, we can basically get the LCM. So in here, for you to get the GCF, you just have to get the factors that are common in 12 and 20. All right. But to get the LCM, we fill in the column of the factors that these two don't have in common, and which are 3 and 5. All right. So we have here 3, and in 12, we have here 5. So in this way, you can notice that this is the multiple which your 12 and 20 have in common. So we have here the LCM of your 12 and 20 is equal to 2 times 2 times 3 times 5, which is equal to 60. And since LCM serves as a dividend, let's divide 60 by the given numbers and see what will happen. So 60 divided by 12 is 5. All right. 60 divided by 20 is 3. And as you notice, the quotient of the LCM and the given numbers are the factors that we filled in just to complete this table, which make this table a lot more sense. All right. And as you can see also, 5 and 3, the quotient of LCM and the given numbers are relatively prime. All right. So let's have another example for you to familiarize this method. So let's have another example, which is in number 3, the problem in the first part, which is we're going to get the LCM of 24, 42, and 60. All right. So to get their LCM, let's get their prime factors and put it in a table like this and see what we can do. So let's start in the factors of 24. So what are the factors of 24? We have here 2 times 2 times 2 times 3. All right. The factors of 42, we have here 2 times 3 times 7. All right. And the factors of 60 are 2 times 2 times 3 times 5. All right. And by putting it in a table like this, let's see what we can do to get the LCM of these three numbers. Just like what we did in the second example, we fill in the column of the factors that these three numbers don't have in common, which are 2 times 2, all right, times 5. You have 5 times 7. In here, you have 2 and 7. All right. So this is the multiple where 24, 42, 60 have in common, and it is the least common multiple. All right. Or the least common multiple of this, which will be equal to 2 times 2 times 2 times 3 times 5 times 7. All right. So you have here 8 times 3, 24 times 3 times 5. You have 120 times 7. You have the LCM of this is 840. All right. And without using the calculator, I can definitely answer this and confidently say that 840 divided by 24 is 35. And 840 divided by 42 is 20. And 840 divided by 60, this will be equal to 14. All right. So without using the calculator, I know the quotients of the LCM and the given numbers by just looking on the factors that we filled to complete the table. These quotients 14, 20, and 35 are all relatively prime. Hence, the LCM of 24, 42, and 60 is 840. All right. So you can use this concept in getting the least common multiple of the denominators in adding or subtracting dissimilar fractions. Example, you're going to get the sum of 1/3 and 1/4. To make the denominators common, just use the concept of LCM and express these fractions in terms of their common denominators. All right. Which is called the least common denominator. All right. So if you have questions or concerns regarding this video, you can write it down in the comment section below. All right. See you next video.